LLM cost control got real for us on a Tuesday night. A research worker hit a flaky source, summarized an empty page, failed verification, retried, found the same source again, and repeated. Nothing looked broken from the outside. The queue was green. The logs were busy. By morning, one small customer report had burned more tokens than the rest of the day combined. The bug was not the model. The bug was that the loop had permission to keep spending until someone noticed. The naive approach is simple. If the agent fails, try again. If the output fails validation, try again. If the tool times out, try again. That sounds reasonable until you remember that every attempt has a price. Tokens, time, tool calls, and operational attention. A monthly spend alert does not protect a single task. By the time finance sees the chart, the loop already ran. Worse, successful tasks can be wasteful. An agent can eventually produce a correct answer after 12 messy attempts, and your system will call that success. In production, that is not success. That is an unpriced liability. The pattern is a retry budget. Before any loop runs, it receives max attempts. Not after the second retry feels suspicious. Not as a config you hope someone remembers. Before the first model call. Then give the task 3 ceilings: token budget, wall clock budget, and dollar budget. Tokens catch context growth. Wall clock catches stuck tools and slow dependencies. Dollars catch mixed model pricing and external services. Track those numbers per task, not just per account or month. When the budget is exhausted, the loop reports budget exhausted with evidence. It does not quietly disappear. Silent stopping is just failure with worse debugging. Mechanically, wrap the loop, not the model call alone. Step 1. Create a budget object with task ID, max attempts, token caps, dollar cap, and deadline. Step 2. Before each iteration, check whether another attempt is allowed. Step 3. Call the model or tool, then record actual usage, not estimates, when actuals are available. Step 4. Run verification. If verification passes, return success with total spend. If it fails and budget remains, continue. If any ceiling is crossed, return a structured budget exhausted result. Attempts used, tokens used, dollars used, last error, and best partial output if safe to return. Take a research loop that answers a customer question from 5 sources. The budget is max attempts 4, wall clock 3 minutes, 30,000 total tokens, and $1.20. Attempt 1 uses a cheap model to draft search queries and summarize sources. A stronger, more expensive model acts as the verdict step. Are the sources relevant? And is the answer supported? If verdict fails, the loop may retry with better queries. Every attempt adds spend to the same task ledger. On attempt 3, the token budget is nearly gone. The wrapper blocks attempt 4 and returns, budget exhausted, 3 attempts used, 29,000 tokens, 98 cents. Verdict failed because source coverage was weak. Budgets are guardrails, not magic. Cost estimates can be wrong if the provider reports usage late or tool pricing changes. Context can grow silently when you append logs, traces, and retrieved documents every round. Parallel subagents are another trap. 5 workers with 3 retries each is not 3 attempts. It is up to 15 model paths. Also, tight caps can reduce quality. That is an honest trade-off. My opinion, make the first budget conservative, measure exhaustion rates, then raise limits only for task classes that prove value. Do not create one giant global cap and call it engineering. Retry budgets sit next to stop conditions. A stop condition says when the loop is done. A retry budget says how much it may spend trying to get done. They also connect to verification gates, because retries should be driven by evidence, not vibes. They depend on state, because you need a task ledger that survives across attempts. Later in the series at fleet scale, we will talk about queues, tenant quotas, back pressure, and scheduling. But the foundation is smaller than that. Every loop gets a price ceiling before it starts. If a single task is not bounded, the fleet will not be bounded either. Here is the 10-minute exercise. Pick one automation you already run, a coding helper, a research script, a content pipeline, anything with retries. Find the loop boundary. Add max attempts before the loop begins. Add a deadline using wall clock time. Add 2 counters, tokens used and estimated dollars used. If you cannot get exact usage yet, start with estimates and mark them as estimates. Then change the failure behavior. When the budget is exhausted, print or return a structured report. Do not return null. Do not pretend nothing happened. Your goal today is not perfect accounting. It is making the worst case visible. 3 beats to keep. First, an unbounded loop is an unbounded invoice, so max attempts must exist before the first call. Second, budget means tokens, wall clock time, and dollars, tracked per task, not guessed from a monthly dashboard. Third, budget exhaustion is a real outcome. Report it with evidence and partial state. Never silently stop. Use cheaper models for drafts and stronger, often more expensive models for verdicts when the verdict matters. This is loop engineering, building agent loops that finish, verify, and stop. New loop engineering episode daily on this channel.